Hi everybody, let's continue to discuss some other questions for these chapters. The variable x and y are related by the equations by. Okay, let me write over here first, b. So be careful, this is b, not 6. by is equal to x plus a over x. Where a and b are constant, the diagram above shows part of a line of best fit obtained by plotting a graph of xy against x squared. So this is xy against x squared. So now later on we know what to do when we want to reduce these non-linear functions to a linear form. The line passes through point 135, 440. 135 and 450. Find the value of a and b. Okay, one thing you have to be careful. This is xy against x squared. This value, the value here is not x but x squared. The value here is not y but xy. Same thing here. So this is x squared and this is xy. Okay, since that we know our axis is xy against x squared, so now we know how to reduce it. First, I don't want the b. I just divide this whole function by b. So I will get divided by b. I will get b. This is y. This is x over b. This is a over bx. And then I notice that I want xy. Here only have y. So what to do is multiply this whole function by x times x. So it will become xy. This will become x squared over b. This will become a over b. I hope that you understand this step. A over bx times x. It cancels out. You will get a over b. Now I try to change the way of writing it so that you can see what is the gradient, what is the y-intercept easily. So this is 1 over b times x squared plus a over b. Y equal to mx plus c. The y-axis is xy, yes, correct. The x-axis is x squared, yes, correct. So that now we know that the gradient of this straight line is actually equal to 1 over b. And the y-intercept of this straight line is equal to a over b. Okay, so let's see how do we get the value of a and b. I get the value of 1 over b first. I know that 1 over b is actually the gradient of this straight line. To find the gradient of these 2 points, I think it should be no problem, right? y2 minus y1 divided by x2 minus x1. Okay, so this is 1 over b, and this is 15, this is 3. 1 over b is equal to 5. And then you know b is equal to 1 over 5. Okay, we got the value of b. The next step is to get the value of a. So I do it over here. Let me use another color. I need to get the value of a. So how about since I already got the value of b, right? I plug in the value of b over here. xy is equal to 1 over b is actually equal to 5. X squared, just copy, plus a over b. b is equal to 1 over 5. Okay, so it will become like this. A. Okay, now we are going to find the value of a. You can use this point or this point. Let's say I use this point. Might be easier because I have 1 here. So at point 1, 35. Remember, this is x squared, this is xy. The xy here is equal to 35 equal to 5 x squared, which is equal to 1 plus 5a. Okay, so this is 35 equal to 5 plus 5a. Bring the 5 over here. 35 minus 5 equal to 5a. So this is 30 equal to 5a. And then now we got the value of a. A is equal to 30 divided by 5. A is equal to 6. Okay, so this is the way how we get the value of a. So some student might thinking this way, might be thinking this way. This is 1 times 35. You get 35. And then this is 1 square. You get 1, right? Actually, this is not a correct way. Just for this point, it's coincident to get the correct answer. Okay, let's try if we use this point. If the method is correct, we will still be able to get the same answer. Okay, I think I do it here. At point 450. Remember, this is x squared and this is xy. Okay, now let me copy this function first. Xy equal to 5x squared plus 5a. Xy is equal to 50. 5 x squared is equal to 4. Don't write 4 squared. This whole thing is actually x squared. 4 minus 5a. Okay, sorry, plus. So this is 50. This is 50. Okay. So 50 minus 20 is equal to 5a. So 5a will be equal to 30. A will be equal to 30 divided by 5, which is also equal to 6. This is the correct way. So if you do another way, this is not correct. Let me show you here. So don't do this way. Okay, let's say some student might do this way. So this is wrong. Let's say at point 450. So let me copy the function first. Xy 5 squared plus 5a. Xy, right? So I write 4 times 50. Then 5x squared, 4 squared plus 5a. Okay, let's see whether we can get the correct answer or not. So this is 200, 这个是16 80 5a. 200 minus 80, you get 120. 120, and this is 5a. Okay, let me check around now this one. 120, 5a, yes. Then a is equal to 120 divided by 5, which is equal to 20. Okay, 120. 20. This is equal to 24. You see, this is not equal to 6. This method is actually not correct. So be careful. Since that the axis is xy, again is x squared. This is x squared. This is xy. Same thing here. This is x squared. This is xy. Okay, let's try next questions. Okay, let's look at these questions. The following table shows the corresponding values of two variables x and y obtained from an experiment. The variable x and y are related by this equation. Y equal to ab power x squared. Okay, where a and b are constant. Using a scale of 2 centimeters 1 unit on the x squared axis. So now the question is telling you what axis that you need to use, x squared. And then 1 unit on the x squared axis and 2 centimeters to 0.2 units on the log base 10 of y axis. Plot the graph of log base 10 of y against x squared. Hence draw the line of best fit. So it means that I need log base 10 of y, and also I need x squared. Okay, so how to get this value? It's easy. So let me copy this table first. Okay, I have copied the table. What I need to do next is add two more rows. One is for x squared and another one is for log base 10 of y. So this is for x squared and this is for log base 10 of y. X squared, you just take every value of x here, square it, 1 square, you get 1, right? 1.00, 1.00, 1.5 square, 2.25. We can just use a calculator to help you. 2.0 square, 4.00, 2.5 square, 6.25, 6.25, and 3.0 square, 9.00. Okay, and log base 10 of y, you just use your calculator to help you. Log base 10 of 1.8, log base 10 of 2.24, and so on. Okay, so in this case, I just take two decimal places, 0.26 and 0.35. This is 0.49. So this is 0.67. And then the last one is, okay, 0.89. 0.89. Okay, let me check around on this one. Log 7.74. Okay, correct. Okay, so the next thing is to plot the graph, and we have to follow the scale requested by the questions. 2 centimeter to 1 units on the x square axis. 1, 2, 3, 4, 5, and then 2 centimeters to 0.2 units on the log y axis, 0.2, 0.4, 0.6, and so on. Okay, so I just use this graph to explain to you, so it will be faster. So plot all the point. To plot the point, I think it should be no problem, right? And then it's very important in this chapter, you need to get a long ruler so that it's easier for you to draw the line of best fit. Okay, so plot all the point, then use your long ruler to help you to get the line of best fit. Okay, so this is a line. So part A, we got the answer. This is the answers. How about part B? So you have to draw the lines of best fit carefully, because we always need to get information from our graph to help us to get the answer for the following part. Okay, so now use your graph in A, this graph, to find the value of A and B. Okay, let me copy this function first. Y equal to AB power x squared. So I want to reduce these non-linear relations. Log base 10 of y, x squared. Okay, so I need to add log to both sides. Okay, this should be no problem. You just break it, become two part, become plus. I need to know the gradients, what is represented by the gradient, and the y-intercept. Okay, I can bring the x squared go down here. X squared, then log base 10 of b. Okay, so now I've rearranged all these terms nicely, so easier for you to know which one is gradient, which one is y-intercept. Okay, let me put a parenthesis here, will be clearer, easier for you to get the answers. Okay, y equal to m x plus c. Y-axis is log base 10 of y, correct or not? Yes, correct. X-axis is x squared, okay, correct. And from here, we know the gradient is actually log base 10 of b, and log base 10 of a is actually the y-intercept. So in this case, from our graph, we know that the y-intercept is 0.18. Okay, let's get the value of a first. Log base 10 of a is a y-intercept. From our graph, we know the y-intercept is 0.18. Okay, here you can use a calculator to tell you a is equal to 10 raised to the power of 0.18. Okay, just press the calculator. 10 to the power of 0.18. 1.514. Okay, so now let's try to get the value of b. So we know that this is actually a gradient, so you can choose any 2 points that fall on the straight line to calculate the gradient. Or if you want to do like this, also can choose any 2 points, then draw a small triangle to get the gradient of that graph. Okay, so I will just follow this answer. According to this, the gradient is, according to this graph, the gradient is 0.63 divided by 8. Okay, so 0.63 divided by 8, you will get 0.07875. Okay, so b is equal to 10 raised to the power of 0.07875. b is equal to 1.199. Okay, I just take 4 significant figures. So this is the value of a and b. Okay, later on you have to try to draw your graph yourself, then only you can master it well. Okay, let's try another questions. Diagram 1 shows part of the graph y equal to a and x, where a and n are constant. Find the value of a and n. So this is y against x. This is a curve non-linear relation. Y equal to a n raised to the power of x. Okay, I think I need to form 2 equations first. At point 1, 1. This is y against x, right? So this is x, this is y. This is x, this is y. So y is equal to 1, a n raised to the power of x, which is equal to 1. So from here I get an equation. A n is equal to 1. Oh. A n is equal to 1. This is the first equation. So how about second equation? At point 1.5, 10. Y is equal to 10. A n raised to the power of 1.5. Now I have the second equation. Okay, so this is the second equation. So now I want to get rid of one of the variable first in order to get the value of one of the variable, the other variable. Okay, so how about I take the second equation divided by the first equation. Take the second one divided by the first one. A n raised to the power 1.5 divided by a n raised to the power 1 is equal to 10 divided by 1. So the a will actually cancel up, and here I will get n raised to the power of nothing. Here is actually 1. 1.5 minus 1, you get 0.5, which is equal to 10. Okay, I write over here. So n raised to the power of 0.5 is actually n raised to the power 1 over 2 is equal to 10. So now I know I square both sides. So n is equal to 100. Okay, so this is the value of n. Once we have the value of n, it will be easier for us to get the value of a. Substitute n equal to 100 into, okay, I think I just choose the first one, will be easier. A times n, which is equal to 100, is equal to 1, right? So A is equal to 1 over 100. A is equal to, you can change it to a decimal if you want, 0.01. Okay, so we got the value of A and N. Let me write down over here. A is equal to 0.01 and then N is equal to 100. Okay, let's proceed to the next part. The equation y equal to a n raised to the power of x is reduced to the linear form y equal to mx plus c, and the line of best fits for the graph of, okay, so this is a graph of log base 10 of y against x, so this is x. Is as shown in the diagram 2. Calculate the value of p and q. Okay, this axis will actually tell us how to reduce the nonlinear relations. So since I already got the value of a and n, I'm going to plug in here. Y equal to a 0.01 and 100 raised to the power of x. So be careful, you cannot take this one times this one because you have a power here. So what to do the next thing? Now we want to reduce it. So from here, we refer to the axis given here. We know what to do, right? I just add log base 10 to both sides because I see here you have a log base 10 of y. And then here do the same thing, log base 10, write a big parenthesis, okay, write a square parenthesis 0.01, okay. So the next thing should be no problem. Same thing, break it become two part, become plus 0.01 plus this is 100 raised to the power of x. Okay, so this you can press your calculator, is equal to -2. It's equal to -2, and then the x you can bring it down here, it become, okay, so this is actually equal to 2. Same thing, you can use your calculator to help you. X times 2. So in order to make it easier to get the value of gradient and y-intercept, I rearrange all this term nicely in the form of y equal to mx plus c. Okay, so let me check correct or not. Log base 10 of y equal to 2x minus 2. Okay, correct. So from here I know that the gradient is equal to 2 and the y-intercept is equal to -2. Calculate the value of p and q. Okay, be careful. Since this is log base 10 of y against x, so this is x and this is not y but log base 10 of y. Same thing for this point. Okay, let's find the point p, the value of p first. Alright, over here. At point p2. Okay, let me copy this whole equation first. This is 2. Be careful. Don't write log base 10 of 2. This whole thing is equal to 2. X is equal to p. Bring the -2 over here. 2 plus 2, you will get 4. It's equal to 2p. Then p is equal to 4 divided by 2, which is equal to 2. Okay, so we do the same thing for the next, when we want to get the value of q. At point 3q. This is q. 2x, which is 3, minus 2. So q is equal to 6 minus 2. Q is equal to 4. Okay, so we got the value of P and Q. Okay, let's try last one. The diagram shows a straight line graph of square root of x over y against 1 over x. Based on the diagram, express y in terms of x. Okay, now refer to that as y equal to mx plus c. In this case, the big Y is equal to this, the big X is equal to this, and gradient we need to find ourselves, and the C is equal to -7, right? Okay, so this I copy over here. M, I can find myself, right? How to get the value of M? Gradient. This is actually 0, -7, right? Now I use this 2 points to help me to get the gradient. 5 minus -7, 8 minus 0. So this is 12, this is 8. So it would be 3 over 2. So gradient is equal to 3 over 2. X is equal to 1 over x. Plus C. C is -7, right? -7. Okay, so the next thing I want to do is to change the subject, become y. I want to express y in terms of x. Okay, so I think this one should be no problem. So 3, this is 2x, this is -7. So now I'm going to combine these two fractions together, become a single fractions. So this is minus. In order to combine these two fractions together, I need to change the denominator here, become the same as this one, 2x. So what I need to do is times 2x times 2x. 7, okay, let me write over here so that you know what I'm doing. 7 times 2x, you will get 14x. 1 times 2x, you will get 2x. Now you will notice that they have the same denominator. I can combine these two together. Okay. So next step is a cross multiplications. 2x times square root of x and y times 3 minus 14x. Next thing, I move this whole thing over here. Y times this. If you bring this whole thing over here, it becomes dy. 3 minus 14x is equal to y. Okay, so now I change the y to the right hand side, left hand side. So normally we like to write the subject on the left hand side. 2x over 2x times square root of x over 3 minus 14x. Okay, let me check correct or not. Okay, so this is the answer for these questions. 2x times square root of x and 3 minus 14x. Okay, so for this video, I just stop here first. So after watching this video, I hope that you understand better. If you think that my video is helpful, make you understand better, if you don't mind, help me to share with your friends who also need this type of videos. And remember to try to solve the questions yourself. See you next time. Thanks for watching. Bye bye.